All right, more examples of multiplying and dividing. And I'm showing you this problem because I want to talk a little bit more about stacking like terms. First off, the obvious thing is that this second expression is going to get flipped over. But I'm going to go ahead and I'm going to factor everything as I flip and just do all this in one go. So 15 is 3 times 5 and x cubed. And then the 4y squared comes to the top, and I'm going to write that as 2 times y squared. And the reason will become sort of obvious in just a second. And on the bottom, I've got 3 times y times, and then 10x squared y, 2 times 5 times x squared times y. And I'm now going to start collecting. I'm going to put the numbers 3 and a 5 and a 2 and a 2 all out front. And I've got an x cubed and I got a y squared. And on the bottom, I've got a 3 and a 5 and a 2. Notice I changed the order a little bit there. And I've got y times y, which is y squared, and I've got an x squared. You'll notice that I chose to stack everything that was alike because this makes life so much easier. 3 over 3, 1, 5 over 5, 2 over 2, y squared over y squared, as long as y is not equal to 0. And x cubed over x squared simplifies to x as long as x is not equal to 0. So this simplifies to 2x with those restrictions. This is a linear function, if I were to graph it, if it were a function, with a hole at the origin. All right, let's do example number 4. Let's do this one. Guys, let's talk about 20 over 22 times 14 over 35. The immediate instinct, and I'll do it in red because it's not a good instinct, is to multiply 20 by 14 and then multiply 22 by 35 and then try to figure out what goes into 280 and 770. And you can maybe see you got some ideas, but it's not the easiest way to do it. Let's factor 20. 2 times 2 times 5, 14, 2 times 7, 22, 2 times 11, 35, 5 times 7. And what I notice now is I've got a 2 and a 2, got a 5 and a 5, I got a 7 and a 7, and when I cross those off, I get 4/11. Much, much easier. I'm going to go to the next page actually for the new example, because what I'm going to throw at you now is 5x squared plus 34x minus 7 over 10x times 5x over x squared plus 4x minus 21. My first step is to factor everything. This factors as 5x minus 1 times x plus 7. This doesn't factor, it stays 5x. This factors as 2 times 5 times x, and this factors as x plus 7 times x minus 3. If I were stacking these, I would say 5 times x times 5x minus 1 times x plus 7 over 2 times 5 times x minus 3 times x plus 7. And what I notice now is that I've got a 1 and I've got a 1. My domain restrictions are x naught 0, x naught negative 7. Those are both holes. And I've got another domain restriction at x naught 3, which is an asymptote. And this expression simplifies to 5x minus 1 over 2 times x minus 3 with the domain restrictions listed over there. There's some discussion about whether you should write that as 2x minus 6 on the bottom. I'm fine with leaving it in factored form. I think that's a personal preference more than anything. So there you go. Lots of examples, multiplying and dividing rational expressions, and why we always factor first. so that we can reduce